In the silent darkness of space, a giant golden eye has opened, a million miles from Earth. This is the James Webb Space Telescope, or JWST, humanity's most powerful tool for exploring the cosmos. Webb is our time machine, peering back over 13 billion years to the dawn of the universe. Webb has detected a chemical signature in the atmosphere of a distant planet, one that could, just possibly, be a sign of life. Webb's mission is to answer the questions that connect us all. Are we alone? Where did we come from? Now, with its first discoveries, we stand at the threshold of a new era. What makes Webb so special? It sees the universe in infrared light, heat, not just color. As the universe expands, ancient light from the first stars is stretched into the infrared, invisible to our eyes. Webb's giant mirror is designed to collect this faint, ancient light, letting us witness the cosmic dawn. Infrared also pierces through cosmic dust, revealing stellar nurseries where new stars and planets are born. Visible light is blocked by dust, but infrared passes through, letting Webb see what's hidden. With its gold-coated mirror and tennis court-sized sun shield, Webb stays cold enough to detect the faintest signals. It's an engineering marvel, floating in space, revealing a universe that's always been there but hidden from us. Webb's infrared vision is its superpower, showing us the heat of creation, the glow of distant paths, and the chemical fingerprints of faraway worlds. This isn't just another telescope, it's a specialized instrument perfectly tuned to answer our biggest questions. Webb's discoveries are already changing our understanding of the cosmos. It's giving us an unprecedented look at the very process of creation. The universe is more dynamic and alive than we ever imagined. With Webb, we're seeing the invisible, and every new image is a revelation. The secrets of the universe are finally within our reach, and this is just the beginning. The news that has everyone talking comes from a planet called K2-18b, orbiting a red dwarf 120 light-years away. We'll never visit it, but with Webb, we can study it from afar. K2-18b is a Hycean world, bigger than Earth, smaller than Neptune, and in its star's habitable zone. This Goldilocks region could allow liquid water to exist, a key ingredient for life. For years, K2-18b has been a prime target in the search for life beyond Earth. Webb used transit spectroscopy. As the planet passes in front of its star, starlight filters through its atmosphere. By analyzing which colors are missing, scientists decode the planet's atmospheric barcode. Webb found carbon-bearing molecules, methane and carbon dioxide, plus hints of a water-rich environment. But the real excitement comes from a much rarer molecule, one produced on Earth almost exclusively by living things. This is the whisper from 120 light-years away, a possible sign of life. The measurement is delicate, like smelling a cake from a mile away, but the signal is there. Webb's discovery has become the center of a new cosmic alert. It's the most compelling potential sign of life we've ever found on an exoplanet. The universe may be more alive than we thought. For the first time, we're not just imagining, we're detecting. The search for life has a new promising lead. Webb's most startling find? A possible hint of dimethyl sulfide, or DMS, a molecule produced on Earth mainly by life. On our planet, DMS comes from ocean phytoplankton. Its presence elsewhere could be a biosignature. The detection is tentative, the signal is weak and needs confirmation. Science demands extraordinary evidence, and this is just the first clue. But even the possibility is electrifying. Alongside DMS, Webb found methane and carbon dioxide, key parts of Earth's carbon cycle. The lack of ammonia supports the idea of a water world with a hydrogen-rich atmosphere. All these clues suggest a complex, possibly life-supporting environment. Webb saw a barcode of light filtered through an alien atmosphere, revealing a watery planet with carbon chemistry, and in that barcode, a faint line, possibly DMS, stands out. It's not proof of life, but it's our most promising lead yet. The greatest detective story of all time has a new chapter. Is there life beyond Earth? Webb has brought us closer than ever to an answer. Imagine you are Webb, floating in the cold vacuum of space, shielded from the sun and Earth. Your gaze is fixed on a faint star in Leo, waiting for K2-18b to pass in front. As the planet transits, your golden mirror collects every photon of starlight. Your near-infrared spectrograph splits the light into a rainbow of invisible colors. In this spectrum, the secrets of K2-18b's atmosphere are hidden. As the planet's atmosphere filters the starlight, dark absorption lines appear, shadows cast by molecules like water vapor, methane, and carbon dioxide. Your instruments record these patterns with incredible precision. Then, you detect a faint, subtle pattern, a possible match for dimethyl sulfide. It's a whisper, not a shout, but it's there. You collect more light, building up the signal, trying to turn that whisper into a clear voice. Your work is done. You've gathered the data. Now, you send this precious information back to Earth across 1,000,000 miles of space. Scientists on Earth will analyze every detail, searching for the truth. Webb's journey is a story written in the language of light. Each observation brings us closer to understanding distant worlds. The universe is vast, but with Webb it feels a little closer. The search for life is no longer science fiction, it's happening now. When Webb's data reached Earth, it sparked excitement and debate among scientists. Dr. Niku Madhusudan, the lead scientist, expressed cautious optimism. Future Webb observations are needed to confirm DMS. Science is careful and methodical. Extraordinary claims require extraordinary evidence. Experts like Dr. Sarah Seeger called the finding provocative, but warned we must rule out non-biological sources for DMS. Could unknown chemistry mimic life's signature? That's the critical question. The burden of proof is high, and the search for life is filled with challenges. We only know life on Earth, so we look for familiar signs, but alien life could be very different. Scientists are cosmic detectives, ruling out every other explanation before declaring a discovery. Still, this is a proof of concept. We can detect faint signals from distant worlds. Webb is just getting started. K218b is only the first chapter. The telescope is working perfectly, ready to continue its search. We are living in a revolutionary era for astronomy. What if it's true? If DMS is confirmed, and no other explanation fits, the impact would be profound. For millennia, we've wondered if we're alone. The discovery of even simple life elsewhere would change everything. It would mean life is not unique to Earth. The universe could be teeming with it. Our place in the cosmos would shift. We'd be just one example among many. This would spark a new age of exploration and science, inspiring generations to come. Funding and curiosity would soar. We'd build new telescopes and missions to learn more. The search for life would become a central human endeavor. Even without confirmation, the possibility brings hope and wonder. The question of alien life is now grounded in real science, not just fiction. Webb's discoveries remind us we are explorers, always reaching for the unknown. Whether K218b is home to life or not, the search itself enriches us. It forces us to look up and ask the biggest questions. The universe feels a little less lonely. What happens next? The journey with K218b is just beginning. Scientists will use Webb to collect more data, hoping to confirm the presence of DMS. Meanwhile, others will model K218b's atmosphere, searching for non-biological explanations. Science means trying to prove yourself wrong. Only then can you be sure you're right. Beyond K218b, Webb will study many more exoplanets, building a catalog of alien atmospheres. Each new world brings us closer to understanding the diversity of planets in our galaxy. K218b may be the first to offer a hint of life, but it won't be the last. We're at the dawn of a new era in comparative planetology. Space exploration isn't just about collecting data, it's about understanding our place in the universe. Every observation is a mirror, reflecting our own curiosity and drive to explore. Webb is more than a telescope, it's an instrument of perspective. It connects us to the cosmos and reminds us there's always more to discover. The story of the universe is still being written. For the first time, we're able to read its newest pages. The next chapter is just beginning.